Welcome to the 4.4 notes part 2. These first two boxes were filled in during part 1. We are not going to do them again, so you should already have these filled in. If not, go watch the part 1 video. What we are going to talk about today is the last two, quadratic in form and sum and difference of cubes. Keep in mind that the whole reason why we're factoring is so that we can solve equations. We will not have enough time to solve equations now before winter break, but we will solve them when we come back from winter break. So I'm actually going to start with the second one. I'm going to start with sum and difference of cubes. And I'm going to compare it to difference of squares over here. If you have two things being subtracted and both of them are perfect squares, this is just a fancy way of saying you do the square root, you take away the squared part, and you make one a plus and one a minus. Here's a real example of this. 4x squared minus 9 would turn into 2x plus 3, 2x minus 3. Because the square root of 4 is 2, the square root of x squared is x, and the square root of 9 is 3. One gets a plus in between, one gets a minus in between. And what we're going to do is go ahead and make ourselves a list really quick of perfect squares. So I'm going to start with 2, 3, 4, 5, and I'm going to go all the way up to 10. Okay, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, 100. And then I'm going to do the same thing below, but for cubes. So 2 cubed is 8, because it's 2 times 2 times 2. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. And then we started getting into some higher numbers. 6 cubed is 216. 7 cubed is 343. And 8 cubed, I'm going to have to do again on my calculator because I don't remember that one, is 512. So part of the reason we're listing these is because I don't think you'll remember what all of the perfect cubes are, and that's fine with me. Okay, hopefully you've had a chance to write some of those down. So you need to know the perfect squares and perfect cubes in order to do these, because over here you're doing that square root. So that changes like the 4 to a 2, the 9 to a 3. Okay. So on difference and sum of cubes, I don't need you to remember these words, difference and sum. All I need you to realize is that they can either be subtracted or added. That's really all that's trying to tell you. And what we're going to do is take the cube roots and put them in this first box. Okay, so to get rid of the third power, we call that a cube. So this is the cube root. So like the cube root of 125 would be 5. It's just like doing the square root. You can do multiple roots. This one's the cube root because you want to get rid of a third power. You can do the fourth root to get rid of a fourth power. And then the other half of the problem is going to be these two are squared. Notice how I'm not saying square root, I'm saying squared. And what I mean by that is you've taken this thing and squared it here, and this thing and squared it here. That's really all that's happening. And then here in the middle, I'm going to write multiply. Because in the middle, you're taking these two things, x and y, and multiplying them together. This will make much more sense once we've seen an example. It's the same thing over here, but you'll notice that the signs are a little different. This is still the cube root of these. These two are still the squareds, and it's still multiplied in the middle. I have a trick for you on the signs, and it's called SOAP. And I'm going to write it up here in the corner. Okay, and so SOAP stands for same, opposite, always, plus. So what I'm going to do is fill in all of the numbers for these parentheses, and then I'm going to go do all the signs, and I'm going to follow soap. Or we're going to wash our hands with soap, because that's what you do during COVID. Here's an actual example. X cubed plus 64. So here's how this pattern works. It's really not as complicated as the formulas make it seem. You're going to do the cube root of x cubed, which is x, and the cube root of 64, which is 4. Not the square root, the cube root. That's how I know to use the 4 instead of the 8. So x and 4. Those are my cube roots. And then you square those two, and that's what goes in the next parentheses. So x squared is x squared. 4 squared is 16. And in the middle, you multiply x times 4, which is 4x. I'm completely ignoring any signs so far. Then I'm going to go fill them in, and I'm going to follow SOAP. The first sign is the same as the problem, so plus. The next one is the opposite. And then the last one is always positive. So, same, opposite, always positive. And then I'm going to go ahead and do the next one too so you can see it. And then I might just think up a random third one so you can see one more. Actually, I'll do one from the homework afterwards. So the cube root of 27x cubed is, well, 27 goes with 3. So this will be 3x. And the cube root of 1 is 1. That is the one number that I didn't put on the list. If you want to go back and add it, you can. But 1 squared is 1, 1 cubed is 1, 1 to the 4th is 1. It's always 1. So I have 3x and 1. Then I'm going to square those two new things. When I square this, I have to square the 3 and the x. So that's going to make 9x squared. And then I'm going to square the 1. And in the middle, I multiply 3x times 1, which is 3x. And then I'm going to go follow my signs. Same, opposite, always positive. The sign is a minus this time, so I'm going to go minus, plus, plus. And there you go. I'm going to come over here and do these two. I'm actually going to change one of them, and then we will do a couple more of these on the homework before we finish. Okay, so these are going to factor just like quadratics. I'm actually not going to show you how to do it with substitution because I think that's just going to confuse people a little bit more. I'm going to change this 8 to a plus because it was supposed to be a plus. So do me a favor and change that really quick before I do this example. So we are going to solve this exactly like we would solve the problem 9x squared minus 18x plus 8. The only difference is that these two have a higher power. So it still works the same way as long as this exponent times 2 is this one. So this exponent times 2 is this one. That's the only rule that we have to follow, and it ends with a constant. So what we would do if we were solving this one is we would do 9 times 8, which is what you have to do whenever there's a number in front of x squared. And 9 times 8 is 72. And then I need to find myself two numbers that multiply to 72 and add to negative 18 in the middle. And I'm going to go ahead and move this back in the box now. 1 and 72, 2 and 36. And then I'm going to go ahead and show you guys this because this is how I figure out my numbers. 72 divided by 2, 36. 72 divided by 3. I'm not even going to try 5 because I know it doesn't go into it because it doesn't end in a 0 or a 5. And that's how you find all the numbers that go into it. Yeah, you might have to do a little bit of work on the calculator if you don't know your multiplication facts very well. Then I'm going to take a second to notice that this adds to a negative, which means I want everything to be negative. Otherwise, they wouldn't multiply to positive 72. And I'm going to look down my list and figure out which ones add up to negative 18. This is negative 22. There we go. Negative 6 and negative 12. And what we do with those two numbers when we find them is we split up the middle term. Now, normally we would make this negative 6x and negative 12x because that's what's in the middle. You just have to make sure it matches the middle term. It has the same exponent in the same variable. So I'm going to keep the 9x to the fourth, and then I'm going to put the negative 6 next to that. And it has to be an x squared because that's what's in the middle. And then the same thing over here. Oops, hang on, that's supposed to be a negative 12. I think I switched to pencil this one, right? Everything after this is a type of factoring that you guys have been killing it at, and that's grouping. And that's where you look at these two together and you say, okay, I can divide 9 and 6 by 3. And these both have an x squared in them. So I'm going to take out 3x squared as my GCF. And then I have 9 divided by 3 is 3. I have x to the fourth here. I'm taking 2 of those powers away. So now I have x squared left. And then negative 6 divided by 3 is negative 2. I had x squared, and I'm taking both of those out here. So now it's just negative 2 without any x's. And then over here, I can divide these both by 4. And since this is negative, if the first thing is negative, you always want to take out a negative 4. So then negative 12 divided by negative 4 is 3. I didn't take out any variables, so it keeps the x squared for right now. And then 8 divided by negative 4 is negative 2. And when you're factoring by grouping, what you want to happen is that these two parentheses are the same. And I know I'm kind of out of space, so I'm going to go ahead and just write this over here. My final answer is the one that matches, the 3x squared minus 2. And then the 3x squared minus 4. Sorry, 1 second. That goes on the outside. And I'll take the lights back on now. Okay. And you're done. You do want to double check if there's an x squared. If these two were perfect squares, then you would have to use difference of squares. And that's why I went over that with you guys. But 3 is not a perfect square, and it's in both of them. So I definitely can't do the difference of squares because 3 is not a perfect square. All right. This one right here is going to solve the same way as the problem 6x, or 64, sorry, x squared minus 25. And we've done these before where you just do the square root and the square root. It's going to be just like that, except when you do the square root of 64x to the fourth, the 64 becomes an 8, and the x to the fourth becomes a 2. Okay, and I'm going to make a little note of this down here. Square root takes the power and multiplies it by 1/2. So if this was to the 6th, this would be x cubed. If it was to the 8th, this would be x to the 4th. So it just takes the power and multiplies it by 1/2. The square root is the 1/2 power. That's not something we've had a lot of time to talk about just yet. Another way of thinking about this is if I were to take 8x squared times 8x squared, you would get the 64 and then x squared times x squared. That's x squared. Add another one. Now it's x to the fourth. So x squared is the thing that you multiply by itself to get back to x to the fourth. And that's what it means when you're doing the square root. And then the square root of 25 is 5. 1 gets a plus, 1 gets a minus. And again, double check your parentheses. These are not perfect squares, so that's your final answer. All right, let's do a couple from the assignment to kind of get on the same page. So I'm going to switch over. Here's the notes one last time. I'm going to do numbers 26 and 27.